So this week we've been working on these two ISECs that we started building last week. And so they are similar to the one Alexis has brought us, but they're 10-gallon buckets instead of 5 gallons to have more room for the insulation. And so they're similar in the same ways where we use the concrete heater with the beads sunk into it and the nichrome wire going through it. And so you can see the tops are lifted off by those like aluminum rings, and in there is more fiberglass insulation covered in the welder's blanket. And we'll see more of that in the diagram here. So see the lids are filled with fiberglass and covered in the welding blanket. And then we use slightly different designs for the plastic one and the metal one. In the plastic one, we had perlite at the bottom because it's a...
Alec?
Yep.
I can see your mouse, so you can use your mouse to identify where you are. Yeah, like right now it's in the perlite.
Okay. Yeah. So perlite on the bottom left here gives our steel sleeve on top of it somewhere to sit that's hard so it doesn't like rock around or slide down. And then on top of that is the heater that I was talking about. And then in the sides, we insulated with fiberglass and then covered that in the welder's blanket up until this steel sleeve here that our cook pot slides into. And so then the difference between that one and our metal bucket is that for the metal bucket, the steel sleeve goes all the way down to the bottom and makes contact with the very bottom of our bucket. And then we have this aluminum sort of landing near the bottom of it that the heater rests on.
I think it's steel.
This sleeve is steel. The part that the heater rests on is aluminum.
Oh, okay.
Yeah, it's just
you
like
could
a
make
aluminum.
it out of steel, though, it'd be fine.
Yeah, it's just harder to get like a steel landing to fit in there.
Yeah.
And so then below that we insulated with rock wool, but fiberglass would have worked just as well, or at least similar. And then the sides were insulated with fiberglass as well. And then again, covered with the welder's blanket at the top. And so on the left, you can see the heater I was talking about with the ceramic beads sunk into concrete. And then it's a little hard to see in the picture, but there's nichrome wire going through all of it that heats up when you connect it to the power. And then in the middle, there's our thermal switch and thermal fuse so that nothing gets too hot. And you can see we glued it up near the top of our steel sleeve that is in the middle of our ISECS. And that orange clamp there is holding it down while the glue sets. And so here's us insulating the plastic ISEC. And you can see this big piece of fiberglass just fits around the steel sleeve. And then on the bottom, there was perlite for this one. And then this, you can see in the middle picture, the cook pot slides into the steel sleeve. And then on the right, we covered that fiberglass with the welding blanket. And then on the bottom of the lid here, down in the middle where it meets, there's also welding blanket covering it. And so we tested them on Tuesday and used them outside yesterday. And you can see they're connected to the solar panels there. And then on the bottom left, you can see how the welder's blanket fits on there. and makes it so that you don't get any fiberglass in the food, and it makes it look a lot better too, which is something we've been considering. And so on the right, you can see all the solar panels we have. And then sometimes we hook up two together so that we can, or two in parallel, to try to stay at maximum power if we don't have like the best angle for the sun. And so then this is the data from when we tested the ISECS inside. This is for the plastic one that I was showing. We heated the water up to about 91 degrees and then let it cool overnight. And so that's the red line is the water and the blue line is the heater. And then we did the same thing for the metal bucket, and that's how we got this data. And then that gold line is the water in the metal bucket, which we heated up to what should have been 100 degrees and then let it cool overnight as well. And then we found the thermal conductivity for each of those. For the metal one, it was about 0.12 watts per Kelvin, and the plastic one was just a little bit better at 0.11 watts per Kelvin. And so for the plastic one, that means that if there's a 100-degree temperature difference between the ambient and inside of our ISEC, then we'll lose about 11 watts. And so you can see the curves are really similar, but the metal ISEC is just a little bit steeper. And so we've still been eating lunch and making food with our ISECs almost every day. And we've been trying new things, like on the bottom left here, we made corn on the cob, and then orzo, which is like a little pasta. And that's what we have for this week.
How was that, Emmanuel?
That was great.
Okay. I want to reiterate, one of the two important things are, I mean, that insulation worked really well. And I think going to a 10-gallon bucket helped quite a bit because you enlarge the insulation, especially if you can make it wider. And this is something for Salma to consider if he's making his own shapes, you know, what size he wants. The other thing is we need support underneath the cooker, the ISEC. And so we put perlite down to make it hard. But in the other one, we ran the sleeve all the way down to the ground. And we thought that would conduct a lot of heat, but it really didn't because both of those curves were very similar. So I'm going to stop the recording.